What we want to look at here in this logarithmic and exponential properties is how we can simplify different expressions by using these various properties. So the first thing that we want to look at is general properties of logs and exponentials. So the first thing that we need to talk about is the idea that the same bases will cancel. Now, when we talk about this, one thing to remember is just that in a log, if there's no base, that base is a 10. And in a natural log, if there's no base, the base is an e. So that way you would know if you're indeed having the same base. So what I mean by same bases cancel, so we're looking at the base of a log and the base of an exponential, meaning that if I had something like log with a base of 2 and the exponential with a base of 2. So kind of think about these as two separate things. Think about I have a log with a base 2, and then I have an exponential with a base of 2. So anytime I have a log and an exponential with the same base, they are going to cancel. Now, when I cancel something, think about that as all being 1 that's going to get canceled. So all of that's going to turn into a 1, and then I'd multiply by my leftover. So 1x, so that's going to equal x. So when we say canceling here, what I mean is that it's going to be 1, okay? It will be the number 1. So let's look at a few examples so we can kind of get an idea. Let's say we have log base 5, 5 to the 4x minus 7. All right, so when I look at this, I'm going to first look at, I have a log with a base 5 and an exponential with a base 5. So I'm going to cancel off those bases, so I'd be left with 4x minus 7, right? I don't need to show multiplying by 1. I would just have whatever is left in that exponent. Okay, let's do one more log, and then we'll look at an exponential. So let's say that we had log 10 to the 3y, all right? So when I look at this, I notice that the log does not have a base, but we know if there's no base, then it's a 10. And then I have an exponential with a base of 10. Therefore, my bases will cancel, and I'd be left with that 3y. Right? We can look at the same idea with it starting as an exponent. All right? So if I reverse this first one here, I would have 2 to the log base 2 of x. That's what this one would look like. I'd be doing the same thing. I've got an exponential base 2, and I've got a log base 2. Those are going to cancel, and I'd be left with just x. So you see, it's the same idea. It's just going to be written a little bit differently. All right, so let's write this other one the same way. So if I was using this next example, it would be 5 to the log base 5, 4x minus 7. So again, I would get to cancel the 5 and the log base 5, and I would be left with 4x minus 7. Right? My next one would look something like 10 to the log 3y. So 10 and log with no base would cancel, and I'd be left with 3y. So I could see it written as a log or written as an exponential. Okay? Now, there's another kind of property hidden in here about ones and zeros. So another property kind of, if you will, is if I have log of any number, it could, let's say it's a 7, and I have a 1 here. No matter what that is, it will become 0. So all of this, it's not the same basis, so they're not going to cancel and be 1. But anytime this number here is a 1, it's going to cancel to be 0 as my answer. All right, so it doesn't matter what number. We could take the natural log 1. Again, it's still going to be 0. We could take log base 9, 1. It's going to cancel, but to be 0. All right, so that's one of our properties. Okay, another property, if I was looking at that as the exponential function, I would reverse this because remember it's an inverse. So if I had 7 to the 0 power, that's what would cancel to become a 1, right? If I had e to the first power, or excuse me, e to the 0 power, that would cancel and be a 1. If I had 9 to the 0 power, that would cancel and be a 1. Right, so that's the other kind of property that we'll see here. So either they have the same base, so they cancel to be whatever's left over, or if it's got a 1 or a 0, they're going to cancel to be the other. So notice that the log had a 1 with it, it canceled to be 0. The exponential had a 0 with it, it canceled to be 1. Okay, so those are the first, we call those just the general properties of logs and exponentials. Okay, now the next property that typically kind of goes along with this idea of a general property is called our change of base. Now this is only for log functions because exponentials, we do not need to change the base to be able to use a calculator or any kind of tool like that. However, in a log function, we do. So in a logarithmic function, the base, remember, is assumed to be a 10. Remember, that's from up here. Our log function is assumed to be a 10. So if we have a base that is not 10, and we need to use our calculator, which we'll look at later when we're solving. So this is really going to be important when we get to solving, okay? But when I have something where I have a base other than 10, I might want to change that base so that I can use the calculator to help me kind of figure out what the number would be, what the estimation is. So it's really simple. All we're going to do is rewrite. So let's say we have log base 7 of 15. All right, so log base 7, 15, all we're going to do is say, well, I would rewrite that as log 15 divided by log 7. Then I can use the calculator to help me answer this. I can type it in like this now, and it'll help me estimate it. So when I type that in, as I said, I could estimate to about 1.39. That's just rounding to the 100th, right? So all this change of base does is it allows me to use my calculator to find some estimation, all right? So let's look at one more just to make sure that we're okay. If we had, say, log base 3 of 45, then I would rewrite that using my change of base formula as log 45 divided by log 3. Then I can use the log button in my calculator to be able to approximate. And doing that, I'd get somewhere about 3.46. Again, these are just rough estimations using the calculator, and I'm rounding here to the nearest hundredth. But the idea is that we know how to change the base, one of our properties, so that when we do start to solve here in the next few the next few sections, then we'll be able to use this property to help us do that. So I should be able to use those properties of same basis canceling to help me simplify, whether it's written as a log or it's written as an exponential. And I should be able to use change of base to take a log function with any base and change it into the common base.